Chemical Engineering, Indian Engineering College. Today I am going to handle the subject Chemical Process Industries on a session Unit Operations. First, what is chemical engineering? Chemical engineering is a group of industries or industrial processes in which the raw materials are changed or separated into useful products. The historical development of chemical engineering as the industrial revolution steamed along, certain basic chemicals quickly became necessary to sustain growth. Examples of sulfuric acid was first among these chemical industries. What is the difference between chemistry and chemical engineering? To know what is chemistry means to create new substances, to study its properties, to investigate all possible pathways for one substance to another. And what is chemical engineering is to design the most optimal technology for a specified substance from raw materials, to develop and discover new technological applications for that materials. What is the meaning of unit in chemical engineering? If we see means this is the feed. The feed is sent into a furnace. Here the furnace is a unit. Next it is sent to a turbine. Turbine is a unit and caustic scrubber. This is also a unit. Then seed dryer. These are units and membrane cooling and distillation. These are the some of the units in chemical engineering. The detailed syllabus of CPI includes overall separation process. In this, we will see the purpose of the separation processes, classification of separation process, mechanism of separation process, separation by phase addition or creation, and separation by barrier, and selection of feasible separation process. And in unit 2 is evaporation. In this, we will see the types of evaporation equipment or operation methods and overall heat transfer coefficients in evaporator. Next, calculation methods for the single effect evaporator and calculation methods of the multiple effect evaporator and condensers for evaporators and evaporations using vapor recompression. And in unit 3, we will see vapor liquid equilibrium reactions, single stage equilibrium contact stages, simple distillation methods, distillation with reflex and MCQ Taylor method, distillation and absorption efficiencies, fractional distillation using enthalpy concentration method, distillation of multiple component mixtures. Next is absorption. In this, we will see types of separation processes and methods, equilibrium relation between the phases, and there are multiple equilibrium contact stages, mass transfer between the phases, continuous humidification process, absorption in a plate and the packed tubber, absorption of concentrated mixtures in the packed tubbers, estimation of mass transfer coefficients for packed tubbers. Next is Unit 5 Extraction. The single stage liquid extraction process. Then the equipment used for the liquid extraction and continuous multi stage countercurrent extraction. Introduction to equipment for liquid solid leaching, equilibrium relationships, and single stage leaching, countercurrent multi stage leaching, and properties of pure supercritical fluids, and process concept in supercritical fluid extraction, and fluid equilibrium and mass transfer in supercritical fluid extraction. Next, what is unit operation? Unit operation is a method of analysis and design of chemical engineering process in terms of individual tasks for operation. It is a way of organizing chemical engineering operation into group of individual tasks and operations. In unit operation, the basic step in the chemical engineering process. Unit operations historical perspective. For all intents and purposes, the chemical engineering profession began in 1888. An effort in 1880 by George Davis to unite these varied professionals to a Society of Chemical Engineers proved unsuccessful. However, this muddled state of affairs was changed in 1888 and Professor Lewis Norton of the Massachusetts Institute of Technology introduced Cruise 18, thereby uniting chemical engineers through formal degree. Other schools such as the University of Pennsylvania and Tulane University quickly followed suit, adding their own four chemical engineering programs in 1892 and 1894 respectively. Here we see the purpose of separation process. In chemistry and chemical engineering, a separation process is used to transform a mixture of substances into two or more. Separation process is used to transform a mixture of two or more compositionally distinct products, varying a few expressions. Almost every element or compound in chemistry and chemical engineering, a separation process is used to transform a mixture of substances into two or more compositionally distinct products. Varying a few exceptions, almost every element or compound is found naturally in an impure state such as mixture of two or more substances. Many times the need to separate it into its individual components arises. Separation applications in the field of chemical engineering are very important. A good example is that of crude oil. Crude oil is a mixture of various hydrocarbons and is valuable in this natural form. Demand is greater, however, for the purified various hydrocarbons such as natural gases, gasoline, diesel, jet fuel, lubricating oils, asphalt, etc. Separation process can essentially be termed as mass transfer process. The classifications can be based on the means of separation, mechanical or chemical. The choice of separation depends on the properties and concentrations of each. Mechanical separations are usually favored if possible due to the lower cost of the operation as compared to the chemical separations. Systems that cannot be separated by purely mechanical means, example crude oil, the chemical separation is the remaining solution. The mixture at hand could exist as a combination of any two or more states: solid, 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 liquid, solid, gas, liquid, 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 gas, 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 solid, liquid, gas mixture, etc. Classification of separation process. In the chemical and other physical processing industries and the food and biological processing industries, many similarities exist in the manner in which they enter in feed materials or modified or processed into final materials or chemical and biological products. We can take these seemingly different chemical, physical, or biological process and break them down into a series of separate and distinct steps that were originally called unit operations. However, the unit operation has largely been superseded by the more modern and descriptive term separation processes. The separation processes are common to all types of diverse processing steps. Fundamental transfer process. Momentum transfer, heat transfer, and mass transfer. This is first one is momentum transfer. This is concerned with the transfer of momentum which occurs in moving media, such as in the separation process or fluid flow, sedimentation, mixing, and filtration. Second one is heat transfer. In this fundamental process, we are concerned with the transfer of heat from one place to another. It occurs in the separation process of drying, evaporation, distillation, and others. Next is mass transfer. Here, mass is being transferred from one place to another distinct place. The basic mechanism is the same, whether the phases are gas, solid, or liquid. This includes distillation, absorption, liquid-liquid extraction, membrane separation, absorption, crystallization, and leaching. Classification of separation process. First one is evaporation. This refers to the evaporation of volatile solvents such as water from non-volatile solute such as salt or any other material in solution. Next is drying. In this operation, volatile liquids, usually water, are removed from solid materials. Next is distillation. This is an operation whereby components of a liquid mixture are separated by boiling because of their difference in their vapor pressures. Next is absorption. In this process, component is removed from the gas stream by treatment with the liquid. Next, membrane separation. This process involves the separation of a solid from a fluid by diffusion of the solid from the liquid or gas through a semi-permeable barrier to another fluid. Liquid-liquid extraction. In this case, a solute in a liquid solution is removed by contacting with another liquid solvent that is relatively immiscible with the solution. Next, absorption. Next absorption. This is in this process, component of a gas or liquid state is removed and absorbed by the solid adsorbent. Next, ion exchange. Certain ions in solution are removed from a liquid by an ion exchange solid. Next, liquid solid leaching. This involves treating a finely divided solid with a liquid that dissolves out and removes a solute contained in the solid. Next, crystallization. If this concerns the removal of a solute, such as the salt from a solution by precipitating the solute from the solution. Mechanical physical separations. These involve separation of solid, liquid, or gases by mechanical means such as filtration, settling, centrifugation, and size reduction. Mechanism of separation process. A mixture to be separated usually originates as a single of the mixture into its constituent chemical species. It is not a spontaneous process. It homogeneous is. If it exists as two or more immiscible phases, it is often best to first use some mechanical means based on the gravity, centrifugal force, pressure reduction, or an electric and or magnetic field to separate the phases. Then appropriate separation techniques are applied to each phase. A schematic diagram of a general separation process is shown. The feed mixture can be vapor, liquid or solid, while the two or more products may differ in composition with each other, and the feed and may differ in phase state from each other and or from the feed. The separation is accomplished by forcing the different chemical species in the feed into different spatial locations by any of five general separation techniques. If we see here, means the food mixture is sent to the which is to be separated is sent to the separation process in which it is separated into product 1, product 2, product N1 and product N. As shown the above figure, the most common industrial technique involves the creation of a second phase that is invisible with the feed phase. The creation is accomplished by energy, heat, or shaft or transfer to or from. or by pressure radiation. Here, the feed is sent to the phase station and it will be converted into phase 1 and phase 2. The second technique is to introduce the second phase into the system in the form of a solvent that selectively dissolves some of the species in the feed mixture. If we are adding that mass separating agent, our feed will be get converted into phase 1 and phase 2. Sixth common but of growing importance is the use of a barrier where restricts and enhances the movement of certain chemical species with respect to other species. If the feed is into the barrier, it is divided into phase 1 and phase 2. Besides the growing importance of techniques that involve the addition of solid particles which act directly or as inert chemicals for other substances so as to cause substitution. Feed is means it will get divided into phase 1 and phase 2. Finally, external feeds of various types or sometimes applied for specialized situations. If feed is sent to a force feed or gradient, at that time it may be get separated into phase 1 and phase 2. For all of the general technologies of figure 1.7, the separations are achieved by enhancing the rate of mass transfer by diffusion of creation species relative to mass transfer of all species by bulk movement with a special particular phase. The driving force on the, in the direction of mass transfer by diffusion is governed by thermodynamics with the usual limitations of equilibrium. Thus, both transport and thermodynamic considerations are crucial in separation. Separation by phase addition or relation. If equation is a homogeneous phase solution, solid, liquid, or gas, and the second immiscible phase must be often be developed or added before the separation of chemical species can be achieved. The second phase is created by energy separation agent and or added as a mass separating agent. When two invisible fluid phases are contacted, intimate, intimate mixing of the two phases is important in enhancing mass transfer rates so that the thermodynamic maximum degree of partiality and species can be approached more rapidly. After phase contact, separation operations completed by employing gravity and the enhanced techniques such as centrifugal force to disengage the two phases. These are the some separation operations based on the phase creation or addition. First one is partial condensation or vaporization, where initial fluid is vapor or liquid, and creation added created or added phase is liquid or vapor, and the separating agent is heat transfer. Separation operation is flash vaporization, and the initial fluid is liquid, and the created or added phase is vapor, and separating agent is pressure reduction. And the separation operation is distillation. Initial or feed phases vapor or liquid, created or added phases vapor and liquid, And separating agent is heat transfer and sometimes work transfer. Next, extractive distillation. Here, initial or feed phase is vapor and or liquid, and creator and or added phases vapor and liquid, and the separating agent is liquid, solvent, and heat transfer. Yes, next, vapor and absorption. Vapor and liquid or the feed. Vapor and liquid or the creator or added phase. Liquid absorbent and heat transfer or the separating agents. Absorption. Vapor is a feed and liquid is a creator or added phase. Separating agent is liquid absorption. For stripping, liquid is feed and vapor is creator or added phase. Stripping vapor is the mass separating agent. Reflexive stripping. Here, vapor and or liquid is the feed and vapor and liquid is the creating or added phase. Stripping vapor and heat transfer is the mass separating agent. Next, revolving techniques. Here, feed is the liquid and vapor is the created or added phase. Heat transfer is the separating agent. Azeotropic distillation, vapor and liquid is the feed, and vapor and liquid is the created or added phase. And liquid entrainer is the separating agent. Next, liquid extraction. Here, liquid is the feed, and the created or added phase is liquid, and the mass separating agent is liquid solvent. Next, when the feed mixture includes biases that differ widely in their tendency to vaporize and condense, partial condensation or partial vaporization, separation operation may be adequate to achieve the desired separation or recover of a particular compound. The degree of species separation achieved by a single partial vaporization or partial condensation is inadequate because the volatility differences among the species in the fluid mixture are not sufficiently large. In that case, it may still be possible to achieve a desired separation of the species in the fluid mixtures without introducing an ESA by employing distillation. In volatility difference between the species to be separated and also small as to necessitate more than about 100 days in the distillation operation. Extractive distillation is often considered here an MSA acting as a solvent is used to increase volatility differences between selected species of the speed, thereby reducing the number of required trays to be reasonable value. If condensation or vapor leaving the top of the distillation column is not easily accomplished by heat transfer to cooling tower or a refrigerant, a liquid MSA called an absorbent may be introduced to the top tray in place of reflex. The resulting separation operation is called three-point absorption. In separation by barrier, the use of microporous and non-porous membranes or semi-permeable barriers for the application to difficult and highly selective separation is rapidly gaining adherence in industrial separation process. Membranes are usually fabricated from natural fibers, synthetic polymers, ceramics, or metals, but they may also consist of liquid films, solid membranes, and are fabricated into flat sheets, tubes, hollow fibers, or spiral wound sheets. For the microporous membrane, separation is affected by differing rates of diffusion through the pores, while for non-porous membrane, separation occurs because of differences in both the solubility in the membrane and the rate of diffusion through the membrane. The following table lists the most widely used membrane separation operations. Stop osmosis operation in the table involves the transfer by a condensation concentration gradient of a solvent through a membrane into a mixture of solute and solvent. The membrane is almost non-permeable to the solute. In reverse osmosis, transport of solvent in the opposite direction is effected by imposing a mixture higher than the osmotic pressure on the feed side. Using a non-porous membrane, reverse osmosis successfully dissolves water. Dialysis is a transport by a concentration gradient of small solute molecules, sometimes called crystalloids, through a porous membrane. The molecules unable to pass through membrane are small, insoluble, non-diffusible particles, sometimes referred to as colloids. Microfiltration refers to the reduction of molecules typically in size range from 0.2 to 10 meter. Exultrofiltration refers to the range from 1 to 20 nanometer to retain even smaller molecules. Reverse osmosis, sometimes called hyperfiltration, can be used down to 0.1 nanometer. Although reverse osmosis can be used to separate organic and aqueous organic liquid mixtures, high pressure or liquid, alternately for evaporation in which the special gases being absorbed by and transported through the non-porous membrane or evaporator can be used. This method, which uses much lower pressures than reverse osmosis, but where the heat of vaporization must be supplied, is used to separate azeotropic mixtures. Excess liquid membranes of only a few molecules in thick can be formed from surfactant containing mixtures that locate at the interface between two fluid phases. With such a membrane, aromatic hydrocarbons can be separated from the paraffin hydrocarbons. Alternatively, the membrane can be separated from the paraffin hydrocarbons by imbibing the microbes with the liquids that are doped with additives to facilitate transport of certain solutes such as CO2 and H2S. Selection of feasible separation process. The selection of a best separation process must frequently be made from among the number of feasible candidates. When the feed mixture is to be separated into more than two products, a combination of two or more operations may be the best. Even when only two products are to be produced, a hybrid process of two or more operations may be most economical. Factors that influence the selection of a feasible separation operation is feed condition. First, in the feed condition composition, particularly the concentration of the feed is to be removed or separated. Second is flow rate. Third one is temperature. Fourth one is pressure. And fifth one is phase spot. Next, product condition. Required purities of products, temperature, pressure, and phase states. Property difference that may be exploited, molecular, thermodynamic and transport, characteristics of separation, operation, ease of scale up, ease of staging, temperature, pressure and phase state requirements, physical size limitations, energy requirements. Some of the some separation operations are well understood and can be readily designed from a mathematical model and are scaled up to a commercial size from laboratory data. The results for a survey shown in the following figure shows that the degree to which the separation operation is technologically mature correlates with the well with the commercial state. Thank you.